So the good news is that even after all the long division, standard division, and remainder theorem, and cubic quartic polynomials, there is a much easier way to find the factors or the zeros of a large, let's say, fifth degree polynomial. Now, the way that we can do that is something called the factor theorem, which states kind of something that should have been obvious to us really all along, which is that if the divisors that we're testing for, or the possible factors that we're testing, are actual factors of the polynomial, then when we just plug them into the x values, the whole function should equal 0. Isn't that what the remainder says? So instead of checking for the remainder of 0, why don't we just plug it in? And then if the entire equation equals 0, we know that it's got to be a factor, because when you plug in that number for x, then it's going to hit at y equals 0. And the only time your graph hits a value of y equals 0 is at the x-intercepts, otherwise known as the factors. So let's say we're asked to use the factor theorem to determine whether we're finding the factors or not. So we have our polynomial over here, x to the 4 minus 2x squared plus 3x minus 4. And we want to know if x plus 2 is a factor. Well, first, let's get the exact x value by setting this bracket to 0. So that would be x plus 2 equals 0, which means that x is negative 2. And so all we got to do is then plug in this value wherever the x's are and see if it equals 0. So we just simply plug in the value of negative 2 into our original polynomial, and we can see that we end up getting a value of negative 2. And so in this case, x plus 2 is not a factor. So we're going to do the same thing here. We're going to figure out if 2x plus 3 is a factor with this polynomial here. So I'm going to set my bracket to 0, which means that x is going to equal 2 minus 3 over 2. Okay, and that of course is just isolating for x over here at that bracket. And we're just going to plug in this value in for the x. And just like the one previously, it doesn't equal 0 when we add up all these numbers, so it is also not a factor. So for the last question in this video, we gave you the function here, 2x cubed plus kx squared minus x plus 6. And this time we know that 2x minus 3 is a factor. Now, if that is a factor, that means that when we take this and we plug it into the x values, that we are going to get an output of 0. So what we're going to do is we're going to plug in these, the 2x minus 3 into the x, and then we're going to isolate for k, which is the only thing that is unknown. And then that's how we can get our final solution, our final function.